screen shake.
And then kind of go in here at the bottom.
Screen shake might seem small, but it's one of the most powerful ways to make your game feel alive. It gives weight to actions, sell the impact of explosions and big events. And it keeps players engaged without them even realizing why. In this video, I'm going to show you exactly how to add screen shake to your Unity game, step by step. With reusable code, you can drop into any project. The system we will build can handle multiple shake requests at the same time, letting each one a chance to contribute to its own impact on the screen. We are going to create two alternative versions of the system, one for Unity's default built-in camera and another for project using Cinemachine. Let's start with a quick explanation how the system works under the hood. Here you can see a timeline representing the player loop in your game. At the core of this solution is a priority list that stores every incoming shake request. Each request has its own duration, amplitude and source position. The list is sorted by amplitude, so the player always feels the strength of the top request. As time passes, new requests may arrive, causing the list to reshuffle, so the most powerful one stays at the top. This ensures we never lose any active shake data while still always presenting the most impactful shake. When a shake's lifespan ends, it's simply removed from the list, and the process continues for as long as there are items remaining. I've already set up a simple demo project for our system. Wherever I click, it sends a shake request to the manager and also shows a nice visual indicator. I can also switch between different profiles to test requests with varying amplitudes and durations. Of course, the shake isn't happening yet because we haven't implemented the manager. All I have now are these two scripts. The shake source defines all the different profiles and capture user input. On mouse clicks, it instantiates a shake effect at the cursor's position. The shake effect is simply a sprite renderer with a pulse animation. Once the animation finishes, the object automatically destroys itself. Alright, let's start by creating a new script and naming it Shake Request Manager. Then open it. First, add a reference to the target camera and define which axis the shake will affect. Next, we will create a priority list we mentioned earlier. For this, we will define a custom private data class to store each request information, such as amplitude, duration, source position, and the remaining lifetime of that individual request. Add a constructor for this class and define the necessary properties. Finally, make sure the class implements the icomparable interface, so we can attach custom sorting logic to it. Now we can start implementing the request manager. First, create a new function to accept shake requests. This function will take all the necessary arguments and add a new shake request instance to our list. If the list has only a single item, we start the shaking process. Otherwise, we sort the list to ensure that the strongest impact presents at the top. Next, we will define the executor coroutine. And don't forget to add any missing imports. We will also add one more field to the manager to store the camera's original position, so we can restore it after all requests are resolved. Inside the while loop, we will track the lifespan of every request. If any expire, we will trigger a cleanup action to ensure no unused data is left behind. Since this is a coroutine, we will yield the main thread while there are active requests. At the end of the executor, we will restore the camera's original position. Finally, we will apply the actual shaking effect to the camera, using a random offset that's updated every frame. We will start by getting the strongest request, calculate the direction from the camera to its source and combine it with a random unit vector. Then we will determine the shake strength based on its remaining lifetime and amplitude, applying a cubic easing function for smooth fall-off. This function comes from my ease function kit package, which provides a variation of static functions for smooth, natural animations instead of plain linear motion. You can also find usage examples there, link in the description. Now let's return the offset multiplied by the axis, so the shake only happens along the desired axis. With that, we have completed the whole shake request manager script. Now let's utilize it in the previously shown shake source script. Create a new field, referencing to the manager, and call the shake request at the same place where we're generating the indicators. All that's left is to attach our new component and set the target camera. Since this is a 2D project, I'm going to set the Z-axis value to 0. Don't forget to add the reference to the source component. And now we can enter play mode to test it. There we go, we have successfully implemented a multi-shake request system that you can drop into any of your projects. Now let's implement the system for Cinemachine. I'm assuming you already have Cinemachine installed. I'm using version 3.1.4 in this video. We will modify the shake request manager. Instead of inheriting from mono behavior, it will now inherit from Cinemachine extension. Because of this, we can remove the target camera and origin fields, along with any other unnecessary code. Next, override the post-pipeline stage callback method. This is where we apply the shake offset to the camera's position. We will also update the getOffset function by wrapping it in an if statement to ensure it only returns a non-trivial offset when there are active shake requests. We will adjust the direction calculation accordingly. After that, remove any unnecessary lines from the executor coroutine. As a nice touch, replace the static easing function with an easing curve field. This lets us tweak easing variations right from the inspector. This class came from the ease kit package we mentioned earlier. Back in Unity, remove the old shake request manager instance from the camera. Now create a new 2D Cinemachine camera, set its tracking target and adjust the lens settings. Click on Add Extension, find our shake manager and add it to the camera. Adjust the axis as needed and feel free to experiment with different easing curves. Finally, wire up this new instance with the shake source component. As you can see, it works just as smoothly as our built-in camera version. I hope you found this video helpful. Thanks for watching, have an awesome day and cheers!